Assalamualaikum. Under the supervision of Pehriya Foundation College, Town campus, this is chemistry class, and today we are going to study the covalent bonds. This is the third main topic of our chapter, and earlier we have discussed about that why do atoms react. And when we got the answer for the why do atoms react, we got the answer that the atoms react to gain stability. For that, atoms can form bonds between the atoms, and one of the bond which we have studied is ionic bond. Now today we have to learn two things. Number one, why only ionic bond was not sufficient for atoms to gain the stability. Obviously, if atoms want to gain stability, why there was a need of another bond, that is covalent bond? First of all, we have to answer this question, that why do only ionic bond, the formation of ionic bond was not sufficient for the atoms to form to gain the stability. Obviously, when we are answering that, atoms basically will bound together, or they do the chemical reaction so that they could get the electronic configuration of the noble gases. So they can get those noble gas electronic configuration by forming only ionic bond. Then why atoms are making the covalent bonds? So we should answer the question first, why there was a need of a covalent bond when there was an ionic bond. To answer this question, just consider that what type of elements were actually making the ionic bonds. These were the metals and the non-metals. The metals were the elements which have the lowest ionization energy, and the non-metals were the elements with the highest ionization energy. Because of their lowest ionization energy, metals were able to lose their electron, and because of the loss of their electron, they were able to form the cations. Similarly, because of the high electron affinity, they had extreme affection towards the electron, and they were able to gain the electron. And as they were able to gain the electron, they were forming the anions. So the cation and anion attraction made them together to form ionic bond, or in other words, the compound was called ionic compound. So for forming an ionic bond, it was compulsory to have either low ionization energy or high electron affinity. One of the two statements, one of the two conditions must acquired so that an element could bond by an ionic bond. But do all of the atoms can form cations? The answer is no. Only the atoms which are known as the metals have the low ionization energy can form the cations. Second question, do all atoms can form anion? So answer to this question is of course no. Only the non-metals with high electron affinity can form the anions. Now answer is that what would happen to the atoms with high ionization energies? What kind of bond the atoms with the high ionization energy would form? Now if we look at the periodic table, and if we look at the trends of ionization energy and electron affinity, we can see the ionization energy and electron affinity, both of them increases from left to right in a period. It means the right region of the periodic table have the ionization energies high as well as the electron affinities very high. We have studied that what kind of bonds would be formed when there would be high electron affinity. We have studied that what kind of bond would be there when there would be have a low electron ionization energy. But now the question arises, what would the bond would be called when the ionization energy would be high? Or in other words, we have studied one more thing, that the metal and non-metals are reacting together to form ionic bond. But what will happen if a non-metal would react with a non-metal? Can a non-metal can react with a non-metal? Earlier, if you have your previous knowledge, you already know this part is not actually the part of your course, but you already know that metals form the bond with the metals, and these kind of bonds are known as the metallic bonds. Now, what kind of bond would be present between a non-metal and a non-metal? Two question arises here. Now, what kind of a bond would be present between a non-metal and a non-metal, and what kind of bond and atom with a high ionization energy would form? Always remember, non-metals have high ionization energy. Because of their high ionization energy, they are unable to lose the electrons. And as they are unable to lose the electrons, they cannot form the cations. Similarly, because of their high ionization energies, they cannot even, if for example, a non-metal is there, as it cannot lose any electron, so the high ionization energy of another non-metal with which it is reacting, the high ion electron affinity of this non-metal would be of no use. The electron affinity was the energy to gain the electron, and it is of no use. Why? Because there is no loss of electron. So such non-metals would rather form the covalent bond between them, and covalent bond is a sharing of electrons between the valence shell electrons between the valence shells of the atoms. So here we can conclude that non-metals form bonds with non-metals. When there is a bond between a non-metal and a non-metal, the bond is formed by the sharing of the electrons in their valence shells. Now take an example of hydrogen. Hydrogen having one electron in its outermost shell come across with another hydrogen which is again a non-metal, and when they fuse together, their valence shell basically fuse together, and at a time they would have two electrons, hence the duplet rule is accomplished. Let's take an example of fluorine. This is hydrogen. Fluorine having 7 electrons in its valence shell, the sides having a single electron would come together and the valence shell would fuse together, hence they would share these two electrons, and they would form the covalent bond. Now if you look at the picture very carefully, actually a pair of electron is being shared between two atoms. One electron is here and one is here. Collectively it is known as a pair. Similarly here, a pair of electron is being shared between the atoms. These pair of electrons get attracted by the both nucleuses. As they are get attracted by the both nucleuses, hence both valence shell can enjoy the presence of both electrons, and this is why their valence shell fuse together and they have a specific space where they would have the octet rule being accomplished. Now there are some things which you should know about the covalent bond. Number one, how covalent bond is represented. Theoretically, when we write about a covalent bond between two atoms, if it is represented by a line, just like that. For example, if I'm showing the covalent bond between hydrogen, I will show it like this. The one more way to show the covalent bond is the electron dot and electron cross structure. Now, what is an electron dot and electron cross structure? Electron dot means representing an electron with a dot, and electron cross means representing an electron with a cross. Here, you should remember that there is no difference between electrons from one electron to electrons. Electrons are always the same. The dot and the cross is only showing you the difference between the two atoms. For example, let's take the example of hydrogen again. If hydrogen is going to react with another hydrogen, rather than representing the electron of the another hydrogen with a dot again, we can represent with a cross. Hence, the fuse structure would tell you that which electron came from which atom. Now, after this fuse, from this fuse structure, you were not able to distinguish that which electron came from which atom. But for this reaction, you can tell that this electron came from this atom and this electron came from this atom. This is the only way how to show the, this is the two ways how to show the representation of a covalent bond. And this electron dot and electron cross structure was basically introduced by G.N. Lewis. So these structures, the electron dot and electron cross structures, are also known as Lewis electronic structures. What are they called? Lewis electronic structures. Now, what here we have to learn two more important things about covalent bond. When we have made the covalent bond between the fluorines, you can see that fluorine had at least 7 electrons in its valence shell, like this, and the second fluorine I will show with a cross structure. And out of these 7 electrons, only one electron from each of an atom was actually contributing in the chemical reaction, or in other words, it was actually for the reason of the formation of a covalent bond. What about the rest of the electrons present in fluorine? These electrons are basically also the part of the valence shell, but they are not the part of the chemical bonding. These electrons are known as lone pairs or unshared pair of electrons, because they are not shared with each other. Unshared pair of electrons. Now they are known as lone pair, although they are not alone, they are together, but they are known as lone pair because they are not together with the electrons of another atom. So here we have 1, 2, 3, 4, 5, 6 lone pairs. Similarly, many atoms can have one lone pair, some could have two, and some could have more. Okay, and these lone pairs have specific property which they govern in a covalent bond, which we will study in the next topic, inshallah. After this, we have the types of the covalent bond. Types of the covalent bond: we have the single covalent bond. Single covalent bond, basically it depends, the types of the covalent bond depend upon the number of electrons which are being shared. If, for example, only one pair of electron is shared, this would be represented by only one line. Hence, this is the single covalent bond. But for example, let's take an example of oxygen. In oxygen, we have 6 electrons in the valence shell. 3, 4, 5 and 6. Similarly, in the second oxygen, we would have 1, 2, 3, 4, 5 and 6. Sorry, I have to mention it with the cross. Now you can see there are 6 electrons in the valence shell, and 2 electrons are basically there which are not paired. All of them are paired, but 2 electrons are not paired. As 2 electrons are not paired, they will form the pair with the electron of the another atom. Hence 2 electrons from each of the atoms would be shared. Or in other words, we can say that 2 electron pairs are shared, and hence one electron pair was forming single bond and the second electron pair would form the double bond. So this would be known as double covalent bond. Similarly, one more type of covalent bond is the triple covalent bond. This is the covalent bond in which 3 pairs of electrons are shared. For example, take an example of nitrogen. Nitrogen have 5 electrons in its valence shell. 1, 2, 3, 4 and 5. Similarly here. 1, 2, 3, 4 and 5. 3 electrons in each of the atoms are unpaired. So they would make the pair with the electrons of the another atom, and the nitrogen bond would be like that. One pair, second pair and the third pair, and as these are 3 pairs, so one pair was making a single bond, other pair was making the double bond, and the third pair would make the triple bond, and hence it is known as the triple covalent bond. And the representation is like this: O double bond O, N double bond N, and for a single bond the representation is like that: H single bond H, F single bond F, etc. So this is all from today's topic. I hope this video would be helpful for you to understand the covalent bond, and you would be able to understand it very carefully and very keenly. Thank you so much. Allah Hafiz.